While you were going about your day in the 1980s, these mechanical giants were silently reshaping entire cities across the globe. From nuclear power plants in the Soviet Union to glittering skyscrapers in Asia, 10 revolutionary cranes didn't just lift steel and concrete, they lifted civilization itself. These engineering marvels could hoist loads equivalent to 100 elephants and reach heights taller than football fields along. This is their untold story. Number 1. K1000, standing nearly 400 feet tall with a 266-foot jib reach. The Kroll K1000 wasn't just a crane, it was a monument to Danish engineering ambition. Designed in 1978 by Chief Engineer Berthold Lang and manufactured through the mid-1980s, this behemoth could lift 120 tons at a radius of 269 feet. With its long jib configuration, it could handle 94 tons at an astounding 330-foot radius. Picture this. The K1000 could rotate 360 degrees on its 40-foot diameter concrete base, covering an area of 7.5 acres, approximately 6 football fields. The crane required 164 massive bolts to secure it to a concrete foundation with a pile depth of 13 meters. Its counterweight system alone weighed 100 tons, and under full load, it could withstand wind speeds up to 175 miles per hour. Between 1976 and the late 1980s, only 15 units were ever built. 13 went to the Soviet Union for nuclear power plant construction, while 2 went to the United States. The first American unit arrived in 1978 for the Forked River nuclear power plant in New Jersey, though fate intervened when the 3 Mile Island disaster struck in 1979, effectively halting nuclear construction. These cranes could reduce construction time on a 4-year nuclear power plant project by 6 to 9 months. In an industry where every month of delay costs millions in interest and lost power generation, the K1000 represented an enormous competitive advantage. Today, most surviving units work as permanently installed dock cranes in shipyards across Norway, Singapore, India, and Iran, a testament to their incredible durability. Number 2. Liebherr Tower Cranes. While Liebherr had been manufacturing cranes since Hans Liebherr invented the modern tower crane in 1949, the 1980s saw the company expand its dominance globally. Liebherr's engineering philosophy combined German precision with practical innovation, creating machines that contractors could rely on in the most demanding conditions. During the 1980s, Liebherr introduced frequency converter technology to crane controls, revolutionizing precision load handling. Their modular tower systems allowed cranes to be configured for different heights and load requirements without complete redesigns. This flexibility made Liebherr cranes essential for everything from residential construction to massive infrastructure projects. What set Liebherr apart was their commitment to safety and efficiency. Their cranes featured advanced load moment sensing systems that automatically adjusted to working conditions. The company's emphasis on using quality steel certified to German DIN standards meant their towers could withstand extreme loads and temperature variations that would compromise lesser machines. By the late 1980s, Liebherr had established itself as one of the world's premier tower crane manufacturers, a position it maintains today. Their cranes dotted skylines from Frankfurt to Singapore, each one representing the cutting edge of lifting technology. Number 3. Potain. Founded in 1928 by Faustin Potain, the company spent the 1960s through 1980s expanding its global footprint through a genius licensing strategy. By the early to mid-1980s, approximately 70% of Potain cranes were being manufactured outside of France through licensing agreements with companies worldwide. Potain's licensing program was extraordinary in scope. They signed agreements with manufacturers in Korea, Singapore, Egypt, Turkey, Mexico, Morocco, India, and numerous other countries throughout the late 1970s. Korean manufacturer Hyundai Heavy Industries alone produced 97 top slewing and 11 bottom slewing Potain cranes under license. But Potain's greatest achievement was arguably in China. In 1965, they licensed the local manufacture of 2 models, the Potain FO23B and H336B, to 3 Chinese enterprises. These designs became the bedrock of what would eventually grow into China's massive domestic crane industry. Potain pioneered top-slewing cranes and later introduced self-erecting models that revolutionized small to medium construction projects. By the 1980s, Potain had become synonymous with innovation, reliability, and global reach. Their cranes built everything from residential apartments to major infrastructure projects across 6 continents. The company's modular design philosophy meant crane components could be easily transported and assembled on-site, reducing setup time and costs. This made Potain cranes particularly attractive for projects in developing nations where infrastructure was limited. Number 4. Demag crawlers. While Demag had roots stretching back to 1819, the company truly came into its own as a crane manufacturer during the 1980s. Demag crawler cranes emerged as market leaders in the lattice boom category, known for their incredible lifting capacity and robust German engineering. The company's lattice boom crawlers could handle enormous loads that would be impossible for conventional cranes. Their modular design allowed for different boom configurations, making them adaptable to various project requirements. From bridge construction to industrial facility assembly, Demag crawlers were the go-to choice for the heaviest lifts. What made Demag special was their attention to ground pressure distribution. Even their largest cranes exerted surprisingly low ground pressure thanks to innovative crawler track designs. This meant they could operate on softer ground conditions where other heavy cranes would simply sink. During the 1980s, Demag's engineering team continuously refined their designs, incorporating hydraulic systems that improved precision and control. Their cranes became favorites on major infrastructure projects worldwide, from highways and bridges to power plants and offshore platforms. The company's commitment to quality was legendary. Each component was manufactured to exacting standards, and their welded joints demanded steel with exceptional resistance to fractures under high loading and low-temperature conditions. This attention to detail meant Demag cranes could work reliably in environments from Arctic cold to desert heat. Number 5. Manitowoc cranes. The Manitowoc Company had been building cranes since acquiring the Moore Speed Crane Company in the 1920s, but the 1980s presented both challenges and opportunities. The recession of the early 1980s and the collapse of the petroleum boom hit Manitowoc's large lift crane business hard, especially in construction and offshore oil industries. However, Manitowoc persevered, and by decade's end had become the only manufacturer of large lift cranes remaining in the United States. All competitors had either sold to foreign interests or gone out of business. The company's revival came partly from the resurgence of offshore drilling in the Gulf of Mexico. Manitowoc had been the first manufacturer to use T1 high-strength steel in booms, design a controlled torque converter for crane applications, and develop extendable crawlers. In 1967, their engineers designed the ringer assembly that doubled the lift capacity of basic cranes. These innovations positioned them perfectly to capitalize on the construction boom that would come in the late 1980s and 90s. Their lattice boom crawler cranes became legendary for their reliability and lifting capacity. From building bridges to erecting office towers, Manitowoc cranes were fixtures on American construction sites throughout the decade, representing homegrown engineering excellence in an increasingly globalized industry. Number 6. City cranes. The early 1980s saw the emergence of a new crane variety, specifically designed for congested urban environments, the city crane. This concept was quickly adopted by most European manufacturers and represented a major innovation in crane design. City cranes were distinguished by towers with reduced cross-section dimensions, making them ideal for tight urban construction sites where space was at a premium. Their appeal was directly related to the increasing congestion of city construction sites, where accidents due to collisions between cranes and other structures were becoming serious concerns. These more compact designs didn't sacrifice capability for size. They could still handle significant loads and reach impressive heights, but their reduced footprint meant they could be positioned closer to buildings and in narrower streets. This was crucial, as cities worldwide experienced construction booms that pushed development into increasingly confined spaces. The city crane concept influenced tower crane design for decades to come, establishing new standards for urban construction equipment. They proved that cranes could be both powerful and space-efficient, a combination that would become increasingly important as urban density increased globally. Number 7. Self-erecting cranes. Throughout the 1980s, manufacturers increasingly adopted hydraulic drives for self-erecting cranes, transforming them from specialized equipment into versatile workhorses. By the end of the decade, the largest self-erectors offered 100-ton meters load moment or more, with reaches extending past 50 meters and hook heights exceeding 40 meters. Self-erecting cranes represented a philosophical shift in crane design. Rather than requiring separate mobile cranes and extensive crews to assemble them, these machines could essentially put themselves together. This dramatically reduced setup time and costs, making them attractive for smaller projects and tight schedules. The hydraulic systems developed during the 1980s gave these cranes unprecedented precision and control. Operators could manage complex lifts with confidence, knowing the hydraulic drives would provide smooth, controlled movements. This technology also improved safety, as hydraulic systems could include automatic overload protection and other safety features. By the 1990s, self-erecting cranes had increased substantially in size and capacity, able to handle work previously requiring standard saddle jib cranes. But it was the innovations of the 1980s that laid the groundwork for this evolution, establishing the fundamental technologies and design principles that made modern self-erectors possible. Number 8. Luffing jib cranes. Luffing jib cranes, which could angle their jibs upward and downward, became increasingly sophisticated during the 1990s. These cranes were essential for high-rise construction in crowded urban environments where horizontal jib movement was restricted by surrounding buildings. The ability to luff or change the angle of the jib meant these cranes could work in spaces where traditional tower cranes simply wouldn't fit. As Asian cities like Hong Kong, Singapore, and Tokyo experienced unprecedented construction booms during the 1980s, luffing jib cranes became indispensable tools. These cranes required sophisticated control systems to manage the complex geometry of luffing movements while maintaining load stability. The control technologies developed in the 1980s made these machines both safe and practical for routine construction work. Operators could precisely position loads even in the most confined spaces, enabling the construction of ever-taller buildings in increasingly dense urban cores. The engineering challenges of luffing jib cranes were substantial. The varying angles meant constantly changing load moments that required real-time calculation and adjustment. The development of electronic load moment indicators and automatic safety systems during the 1980s made these cranes reliable enough for widespread use. Number 9. Hydraulic lattice boom cranes. While mechanical lattice boom truck and crawler cranes dominated through much of the 1970s, the 1980s saw the gradual ascendance of hydraulic lattice boom cranes. Technical limitations in hydraulic and automotive components had previously constrained development, but by the 1980s, these barriers were falling. Hydraulic systems offered several advantages over purely mechanical drives. They provided infinitely variable speed control, allowing operators to match crane movements precisely to task requirements. Hydraulic drives could also incorporate sophisticated load sensing and automatic adjustment features impossible with mechanical systems. Demag emerged as a market leader in hydraulic lattice boom crawlers during this period, combining traditional German engineering excellence with cutting-edge hydraulic technology. Their cranes could handle enormous loads with a precision that seemed almost impossible given their scale. The transition from mechanical to hydraulic systems represented one of the major technological shifts in crane history. By the late 1980s, hydraulic drives had become standard on new large cranes, setting the stage for the advanced computer-controlled machines that would follow in the 1990s and beyond. Number 10. Offshore and specialized cranes. The 1980s oil boom created enormous demand for specialized offshore cranes capable of working on drilling platforms and support vessels. These machines operated in some of the harshest environments imaginable: salt spray, high winds, and constant motion from ocean swells. Offshore cranes required special corrosion-resistant materials and weatherproofing that went far beyond what land-based cranes needed. They also had to be designed for the unique challenges of working on platforms where every square foot of deck space was precious. Many incorporated luffing jibs to minimize their footprint while maximizing their working envelope. These specialized machines often worked alongside massive offshore platforms in the North Sea, Gulf of Mexico, and other oil-producing regions. They lifted everything from drilling equipment weighing hundreds of tons to delicate scientific instruments requiring millimeter precision. The ability to perform both heavy lifts and precision placement in challenging conditions made them invaluable. The offshore crane sector drove numerous innovations that eventually made their way to land-based cranes. Remote monitoring systems, advanced corrosion protection, and enhanced safety features all originated in the demanding offshore environment before being adapted for construction cranes. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.